Hi friends, in this session of probability, we study about the Bayes theorem. In 18th century, Reverend Thomas Bayes, an English Presbyterian minister, raised a question: does God really exist? To answer this question, he attempted to develop a formula to determine the probability that God does exist, based on evidence that was available to him on earth. Later, Laplace refined Bayes' work and gave it the name Bayes theorem. Bayes theorem is useful in revising original probability estimates of known outcomes as we gain additional information about these outcomes. The prior probabilities, when changed in the light of new information, are called revised or posterior probabilities. So, in other words, we could say that a method to compute posterior probabilities is called Bayes theorem. Basically, it is an extended form of conditional probability. So look at here, probability of AI given B is equal to probability of AI intersection B over probability of B, where the probability of AI intersection B is equal to probability of AI into probability of B given AI. Here we get P of AI into P of B over AI over P of B. Or if we derive this, look at here, in other words, or we could write this formula in this way. If we derive this, P of AI given B is equal to P of AI into P of B given AI over P of A1 into P of B given A1 plus P of A2 into P of B given A2 and so on up to AN. So P of AN into P of B given AN. So here we use this formula to solve the problems related to the posterior probabilities. Let us see one tete-a-tete example. 3 uns contain 6 red, 4 black, 4 red, 6 black, 5 red, 5 black balls respectively. One of the uns is selected at random and a ball is drawn from it. If the ball drawn is red, find the probability that it is drawn from first un. So we have 3 uns we have. So we know that the probability of selection of uns would be same. So we see E1 is the event. E1 is the event of selecting first term. E2 is the event of selecting second arm, and E3 is the event of selecting third arm, and A is the event of getting a red ball. So getting a red ball from first arm is equal to probability of A over E1, A given E1, which is, we know that the number of red ball is 6 and the total number of ball red and black are 10. 6 plus 4 is 10. So 6 over 10 we have. Now getting a red ball from second arm is equal to P of A given E2. In the second arm, look at here, in the second arm there are 4 red ball and 6 black ball. The total number balls are 10 and the red ball is 4. So 4 over 10 we have to write down here. And getting a red ball from third arm is equal to P of A given E3 is equal to, in the third arm you see here we have 5 red and 5 black balls, so we have 5 favorable outcomes and 10 total outcomes, 5 over 10. Here we get 5 over 10. And look at here, the events, the selecting of any one of the arms are same in the size and the color, so we get the same probability of selecting an arm from out of these 3. So we get the probability 1 by 3, 1 by 3, 1 by 3. So here we get finally probability of E1 selecting first arm is 1 over 3. Probability of E2 is also 1 over 3, and probability of E3 is also 1 by 3, because these are the mutually exclusive, equally likely and exhaustive. So 1 by 3, 1 by 3, 1 by 3 we are getting here. Now look at here what we have to find out. If the ball drawn is red, one ball is drawn from an arm which is selected randomly, and we have to find the probability that it is drawn from the first arm. So the A is given to us, the ball is red, and we have to find the ball is came from first arm, so E1, it is came from E1, so E1 over A we have to find out. We have to find out probability of E1 over A. This we have to find out. So by the Bayes theorem we have to write down here P of A over E1 into probability of E1. Okay, in denominator we have to write down all the conditional probabilities intersection we have to write down here. So the probability of A over E1 into probability of E1 plus probability of A over E2 into probability of E2 plus probability of A over E3 into probability of E3. We have to write down here in this way. Now we put down these values here in this formula. So we get here probability of E1 over A, probability of A over E1, look at here, which is 6 over 10. So we will write here 6 over 10 into probability of E1. Probability of E1 is 1 over 3. It is 1 over 3. In denominator, the same thing we have to write here, 6 over 10 into 1 over 3 plus probability of A over E2. A given E2 is 4 over 10. So we have to write down here 4 over 10 into the probability of E2 is 1 by 3. So we have to write down here 1 by 3. And the third one, probability of A given E3. So probability of A given E3 is 5 over 10. So we have to write down here 5 over 10 into probability of E3 is 1 over 3. Now we simplify this. It is 6 over 30. In denominator, it is 6 over 30 plus 4 over 30 plus 5 over 30. In denominator, we take 30 common. It is 6 over 30 In denominator 6 plus 4 plus 5 over 30. 30 is common in all, so we take it common. So 30 and 30 will eliminate each other. Now we see is equal to 6 over 15. 6 plus 4, 10, 5, 15. We simplify this. 3 2 times, 3 5 times. So we get here 2 over 5, which is the probability of getting a red ball which is from first on. So it is E1 over A we have got here. So in this way we could use the Bayes theorem to find out the posterior probability problems using the conditional probability methodology. Thank you.